Hi there. So we are trying to analyze how to design low power differential amplifier or low power difference amplifier. So here you can see is a circuit schematic for a differential amplifier where I have used an operational amplifier with its positive supply pin and the negative supply pin. So if I wish to design a low power difference amplifier, so the operational amplifier will be operated with the lower possible supply voltages. So I have chosen V plus and V minus is equal to 1.8 volts. So nowadays we have lower supply voltages for the circuits, and that's why we get the low power designs and the low power circuits and the systems uh, to 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 our variety of portable devices and the wearable devices. So you have V1 and V2. They are the two inputs that you will apply. And then you use the component values of R1, R3, R2, and R4. And the values I have chosen, you can see that R1 and R3 is 10 mega ohm each. R2 is chosen to be 20 mega ohm. And then I have two capacitors C1 and C2, both having the value of 10 picofarad, as you can see that. Now we know, as in our previous modules, we have derived an expression by applying a superposition law. For example, we take the two outputs, VO equal to VO1 plus VO2. So VO1 is the output when only V1 is acting alone with V2 is equal to 0. And VO2 is the output we get when only V2 is acting alone and V1 is connected to the ground. And then we sum these two voltages to get the final output. And that final output expression is given as by this equation. So that is R4 divided by R3 plus R4, and in bracket 1 plus R2 over R1 V2 minus in bracket R2 over R1 multiplied by V1. And if we say that R1 is equal to R3 and R2 is equal to R4, so we do some adjustment by selecting the equal values of the resistors for R1 and R3 and R2 and R4. Then plugging those values into equation 1 here, we get the final form of the output, which is a gain multiplied by the difference between the two inputs, where gain is R2 over R1. Note the sign is positive. So here you have this expression, gain times VID, where you can write gain is multiplied by V2 minus V1. And C1 and C2 are also applied. C2 is there to create the first pole frequency, because when you will simulate the AC response of this circuit, then you will have the Bode plot, which will give you the magnitude of the gain, which is the A, okay, and versus the frequency. So here somewhere you will have minus 3 dB point, and therefore you will have this cutoff frequency that is set over 1 over 2 pi RC. And what is that value of R is R2 and C2, that is in the feedback. So R2 C2 will form the first pole and the dominant pole in the circuit. So this is how you see now the value of R1 and R3 are 10 mega ohm, and the value of R2 is also 20 mega ohm. So choosing a high value of resistances, make sure that the bias currents are at the very low level, and therefore you can design a low power difference amplifier. Also, the supply limits are chosen to be plus minus 1.8 volts. So V plus is 1.8 volt, V minus is minus 1.8 volt. Okay.